Hey guys, hoping all's well with everyone. So in this video, we are going to be looking at our question of the day, which revolves around 7th grade level math and focuses a lot on exponents as well as the properties and characteristics of laws of exponents. So when we look at our problem here, we're asked to simplify the expression and evaluate all exponents. Now, I'm going to be showing you two ways to do this. The first one is going to be very in detail, and it's going to show a lot of application of several laws of exponents taking place in the same problem. And then the other one I'm going to show you is more of just strict evaluation, but more of showing how you can get the same answer, but it's more, again, what's most comfortable for you. So the first thing I want to point out is just two things about this problem that kind of being very vigilant and observant can really set you up for success just by being very organized, especially with a exponents type problem like so. The first thing I want to call your attention to is that you'll notice that all of the bases of this expression are the same, and it's likely meant to do so in the application of these laws of exponents we're going to be applying. But one thing I want to call your attention to is that this 3/4 here on the left doesn't have an exponent on it. You are more than welcome to put a 1 there for housekeeping purposes if you find it beneficial. You're going to be applying, again, a lot of exponent laws here, so that one can be very handy in keeping things clean. The other one that I want to call your attention to, it's not really a deal breaker, but going forward in math, you're going to find that sometimes the way that division problems are formatted don't always set you up for the most success. Especially with exponent type problems like this, and using a quotient of powers application, it's very easier to see things in a fraction type form. Now, I know that can be a little triggering because of the fact that you're gonna get complex fractions with this type of setup, but that's okay because we're gonna be keeping things very clean with that exponent on the 3/4 that we talked about. The application of the laws of exponents we're going to be using are going to be very step by step. So I'm going to represent this division problem as a complex fraction, but I'm again going to be keeping all of the exponents accountable. So the numerator is just going to be the 3/4 here. And then that bracket to the right side of that division sign tells me that everything that remains is going to be in the denominator. So we have 3/4 to the 0 power times 3/4 squared, or to the 2nd power, all in the denominator. Now, if you consider it, I haven't really done anything yet to solve the problem, but I have reformatted it in a way that is very clean and, again, very organized. But now we can start approaching solving the problem. So step number 1 is going to be using the product of powers property to simplify the denominator into a single term. Okay, so remember, your product of powers property tells us that if there are two expressions with the same base and they're being multiplied, then we can take the summation of their exponents and have it be one single expression, with the exponent being the addition of those two individual exponents. So we're going to go ahead, and the numerator I can't simplify. It's kind of just hanging out there. But again, our goal is to simplify the denominator by using that law of exponents. And again, another application that you could have taken here is using the 0th power property, in the fact that any base to the 0 power is 1, but we'll take it a little bit of a different approach with this one. So we're going to take 3/4 to the 0 times 3/4 squared, or to the second power, and that's going to give us an equal expression or equivalent expression of 3/4. I'm still going to keep it to the first power, and I'm going to mark that first exponent there. And then I'm going to take, this will then become 3/4. The base will stay the same, to the 0 plus 2 power, which is going to give us a final equivalent expression for the moment of 3/4 to the first over 3/4 squared. And if you think about it, that makes sense, especially for the denominator, because if we did apply the 0th power property, that would have just, that 3/4 to the 0 would have just become 1, and it would have been 1 times 3/4 squared, which we still end up with in our simplification. So we're on the right track, and again, you could have chosen which properties to use, whichever is most comfortable for you. Step number 2 is going to be using the quotient of powers property to simplify the expression into a single term. So this is essentially eliminating the fraction component of our expression. So remember, very similarly to the product of powers property, the quotient of powers property tells us that if we have a quotient of two bases that are the exact same, then we can subtract their exponents, or take the difference of their exponents, to make it a single expression. So here we have 3/4 to the 1, or to the first. And again, this is where putting the 1 as a placeholder really does justice here. Now keep in mind here that again, we are going to be subtracting these, and if you're looking into the future here, you're going to notice that we do get a negative exponent, and I want to reassure you that is okay. So we have 3/4 to the 1 minus 2. So we're going to get a final equivalent expression of 3/4 to the negative 1. Now, I will caution you on a couple of things here. Number one is, in a lot of tests and exams that you will be taking going forward, if they are free response, your teacher will likely ask you to evaluate and, again, not leave your answer with any exponents. The second one is that if it's a standardized test, likely a lot of the times you'll get a question that states to represent your answer using positive exponents. So the attributes of negative exponents is that in order to create a positive one, we are going to be taking the reciprocal fraction. Now in this case, our fraction has a defined numerator and denominator that are both non-1. They're not 1 in either the numerator or the denominator. But remember that you can represent any whole number as a rational number of itself over the denominator of 1. But in this case, we can simply take the reciprocal fraction of 3/4 and make that equivalent to 4/3 to the positive 1 exponent. So that's essentially what negative exponents look at in terms of their relationship with positive exponents. They're just the reciprocal. So step number 3 is, let's transform the negative exponent on the base by taking the reciprocal fraction perfect. So putting this visually, we have 3/4 to the -1 is equal to, and then I'll show the flip, now this will be to the first power. Now, one thing I also want you to keep in mind is at this point, we are finished with this problem. There is nothing more for us to do. If we were to use the quotient property and we were to get something after we took the reciprocal and got 4/3 to a exponent that was not 1, we would have to do more work. But because it does simplify to the +1, that 1 exponent is again inferred. Again, we can use it as a placeholder in the beginning, but at this point, 4/3 will be our final answer. Now, going back to the very beginning, I mentioned that another way that you can approach this is just by evaluating the exponents of each of the bases and then taking the operation of dividing the fractions. So let's go ahead and do that just so you can see. I'll use a different color. So 3/4 to the first power is just 3/4. Again, it's a very nice placeholder for keeping things organized. I'll keep the division symbol there. And then if you were to evaluate this, 3/4 to the 0 power again applies that 0 power property, which means any base taken to the 0 power is 1. And then if you apply the squaring of the fraction, 3 squared is 9 and 4 squared is 16. So this is going to give us that the equivalent expression we're going to be solving is 3/4 divided by 9/16. Now keep in mind that when we were in earlier grades and we were learning about division of fractions, we found the easier way around the division of fractions by multiplying by the reciprocal of the second fraction. We also may be familiar with the keep, change, flip approach. So we can go ahead and do that to solve this division of fractions here. So we have 3/4 times the reciprocal of my second fraction, which will be 16/9. And then you could go ahead and multiply this through and you would get 48/36. But you can also eliminate common factors here. So you can, because everything is multiplied, you can cancel common factors out. So 16/4 just becomes 4/1. And then 3/9 just becomes 1/3. And then that again would reduce to 4/3. And again, if you did 48/36, you would see that your common factor, your greatest common factor, I believe, would be 12. And then you would be able to, again, see that ratio or equivalent reduced fraction or simplest term fraction to 4/3. But I hope this helps you guys out. I know it covers a lot of different properties of exponents and the application of fractions with exponents, but I hope this helps you guys out. If you have any questions about any of the steps, or if you took a totally different way of approaching this, I would love to see the path that you took to solving it. But I thank you guys so much for watching. Please take good care of yourselves and be safe, and we look forward to seeing you next time in our question of the day. Bye.